Hi friends! Hello November! It's early November now, so we have another 4 more weeks to go. So today is lesson 21. So let's continue with our graph, and this time we will include ln or exponential. Alright? Let's check our previous work first. Okay, so for example 2, okay, according to your graph here, right, your y-intercept supposed to be following your graph. So in my case is 2.2. So if your graph is not 2.2, it's 2.1, so I may need you to change your C here, okay, your C here, change to the y-intercept that you have according to your own graph, okay, to your own graph. So you may need to change your this log A here. Log A equals to your 2 point something. Okay, it must be 2 point something, not far away. I have marked your PDF, and please open it and double check if your work is correct or wrong, right? And it will affect your final answer here, part 3 here, which is your 5,100, but it will be somewhere around there. So please tick for me after you check your PDF and double check again with me here, right? And your part 3. Right, so for question 2, okay, I will be marking Ryan from Year 9 Science 2's work. Okay, so for his graph is here. It's a very neat graph, very good with a label there. Okay, and then I'll normally check on the y-intercept here. So if the y-intercept here is, this is 1.05, then I will check his C. His y-intercept, okay, this is 1.05, because 1.1 is here, 1.2, 1.3, 1.4. So this is 1.05, okay, according to his y-intercept. So this C over here must be 1.05 as well. Okay, so this one must change because this is not 1.15. And then gradient is 0.4, yeah, okay, it's correct. So the B is 2.51 is correct because of his gradient is 0.4, so bring it down here, so it's correct. But as for his A, okay, because it's not 1.15, according to the graph is 1.05, then this one must change, okay? This one you press calculator and change it again, and it will affect your final answer here because this A will be this, okay? So the y here, when x equals to 10, it will be something different again. Alright, so please double check your C, your y-intercept from your graph, okay? And the answer here, part 3, you might be surprised that the range of answer is somewhere around 80,000 to 150,000. Yes, it's that big because of the log, okay? Because of the log, the value of the log here. Okay, so that's all for question 2 here. Okay, so for example 3, there's a little bit different besides the exponential, right? You read the questions, you copy the questions, or if you can, you scan it and print it out and stick it into your notebook. Or if you choose to copy, go ahead, alright? Okay, so a little bit different here. You look at part 1, okay? You have an equation here, of course, y equals to PEQX. So you have an exponential there, right? Right. So part 1 here, they ask you to explain how the straight line graph may be plotted. If you notice example 1 and example 2, okay, they already ask you plot y against x. They tell you what is y, what is big Y, what is big X. But this example 3 in part 1, they didn't mention what is their big Y and what is their big X. So you cannot construct the table straight away, right? Because your first step will be construct new table. For now, you cannot construct new table because you don't know, you are not given any big Y and big X. But they first ask you to explain how the straight line graph may be plotted. Okay, and they already give you the equation over here. So what we're gonna do here is a little bit different now. You don't construct new table first. What you need to do is you need to know what is your big Y and big X. So before you need to know what is your big Y, big X, the information is given is only the non-linear equation over here. So what you're gonna do with this equation over here is you need to reduce first. So your first step is to reduce until you get your big Y and big X. Okay? And don't forget include your M and C as well. So your step now is different. You put reducing first before you construct new table. Right? So I'm gonna do this together with you. So from the equation here, okay, y equals to PEQX. Okay, this QX is power, is on the top here. So what I'm gonna do here is I will reduce this. Okay, I'm gonna reduce this. So what I'm gonna do is I ln both sides. Okay, why ln? Because of the e here, exponential here. Okay, so when I ln both sides, this one I break it into. This is the beginning of the lesson from this topic. If you remember, you can do it, or if not, you can refer back, or you can refer to here. So ln y equals to ln p plus qx, I bring it down, and this ln e is equals to 1. Okay, this ln e equals to 1 according to the law of log, right? So now, okay, I will do it properly here. If you don't want to exchange this and you know that this is m and x, then it's okay. If not, then I arrange this for you to see what is your y, big Y. So your variable is these two, okay, and your m and c is this one. Okay, I'll write down like this. Your big Y equals to ln y, and x is x, and your m is q, and your c, y-intercept, is ln p. Okay, so what's important here is these two things. Your big Y equals to y, and your big X equals to X. We need this because we want to construct a new table. Okay, now I'm gonna construct a new table here. Okay, so your big X will be your still X, and your Y will be ln Y, ln Y. Okay, so now we press calculator according to the table here. You don't draw the graph using this xy again. If you use this xy, you won't get a straight line. So you must convert this to this. And one more thing is, because some of you may be a little bit careless when you press calculator, right? So when you press calculator here, okay, even though if you're using this one as your graph, okay, you're plotting using this, and if you find out that your graph is not straight line, there must be something wrong with the value that you count here. So you must double check from the value xy. You double check by pressing calculator again, whether you got pressed wrong calculator or did you copy down wrongly, right? So your tips here is, when you draw a line and it's not straight, you find out that it's not a straight one line only, one straight line, then you double check your work here. Okay, so for now, okay, your x is still the same. Okay, x still the same, so I'm gonna copy down all the x here. 0, 5, 10, 15, 20. Okay, and your ln y, okay, will be ln 27, ln 14.7, and so on, and bring it down over here. Okay, so I'm gonna press this calculator. So ln 27 is 3.30, okay, 2 decimal place, and 14.7, ln 14.7, 2.69, and then ln 8.1 is 2.09, and for 4.3 is 1.46, and then ln 2.4 is 0.88. Please double check for me, please press calculator, mine wrong leh, okay, so you need to plot the graph, but then first they ask you to explain, right? So your explanation is here. This is your working. So when you need to explain, you explain like this, part 1. So you're gonna say that plot y equals to ln y against x equals to x. If you don't want to write this one, also okay, right? Or you can just write plot ln y against x, okay, to get a straight line. Okay, but you must show the working over here lah. So part 1, your answer is just like that. So how straight line may be plotted? You plot ln y against x with the working here, and then you plot the straight line by constructing a new table, and then you're gonna draw the graph. Okay, so the scale here, you can follow my scale. Okay, so what I'm gonna use here is my x-axis. I will use 2 centimeter to 5 units, and for y-axis I will use 2 cm to 0.5 units. Okay, so I'm gonna plot first. So 0, 5, 10, 15, 20. then 0.5, 1.5, 2, 2.5, and 3. Okay, I normally see what is the biggest value here. The biggest value is 20, so I put until 20. And this value, the biggest is 3.3, so my highest will be until 3.5. Don't forget to label L and Y and your X. I draw my y-axis and x-axis already, the line, so now I'm going to plot the graph. Okay, so first plot is 0, 3.3, so 3.1 here, 3.2, 3.3, so they here, and then 5, 2.69, 5, 2.69, 2.69 is somewhere around 2.7, 2.6, 2.7 is here, then 10 to 2.09, 10 to 0.9 means around 2.10 or 2.1 here, right? And then 15, 1.46, 4 here, 4.5 here, so near to 1.45, and then 20 is 0.88, 0.88 is near to 0.9, so it's here. Okay, so I'm gonna draw the straight line. So this is my straight line. Alright, so this is coming from my part 1. After explanation here, this one, plot L and Y against X. And I'm showing all my Y, X, M, and C. And then I draw this graph. And then part 2. Okay, part 2 here, you look at part 2 and part 3. Part 2 and part 3 use your graph. So no matter what, you must use your graph to get the answer. If you don't use your graph to get the answer, it will be wrong, even though your answer is correct. Okay, so part 2, use your graph to estimate the value of P and Q. Okay, so this one I think you know already. So you can find gradient and find C. Okay, so I'm gonna do it here, part 2. Okay, I'm gonna find gradient. Okay, I'm gonna find gradient using the point that you already plot, 0, 3.3, and 5, 2.69. Okay, I'm gonna use this. So 2.69 minus 3.30 over 5 minus 0, and then I press calculator, goes to negative 0.122. Right, so C is already here, which is 3.3, so my C is 3.3 or 3.30. Okay, and I form my equation, big Y equals to negative 0.122, big X plus 3.3. My big Y is ln Y, negative 0.122, small x plus 3.3. And then I compare with the equation that I've already reduced over here earlier on. So I bring it down, okay, and then compare. So ln Y equals to QX plus ln P. Okay, so we can compare already. My gradient is this, and then my 3.3 is ln P. Okay, so Q equals to negative 0.122. That's my answer in 3 significant figure already. And my ln P, this whole thing equals to 3.3. So how do I move this ln? Okay, I've already write down some recaps over here. Hope you can remember. So what I'm gonna do is I'm gonna move ln, so E 3.3 and 3 sig fig is 27.1. Okay, and then for part 2, this is part 2, right? And then part 3, as I say, use your graph. Okay, you're gonna use your graph to find the answer. Unlike in example 2, I need to sub in my y equals to 9 into the equation here, right? Everything sub in here, including my P and Q. But this time you use your graph to find the answer. Okay, so it's kind of different now. Okay, you don't use that method of sub in here. If you sub in here, that is not using your graph anymore. Alright, so how do you use your graph? Okay, I'm gonna write my part 3 answer here. You write here lah. Gonna write here because it's near to my graph. Okay, so when your y equals to 9, from your graph there is no y equals to 9. You only have ln y. So what you need to do is ln 9. You sub in the 9 into the y, ln 9. Then you press calculator. You get 2.20. Okay, and then you find 2.20 from your graph. 2.20 is over here, down, and then down until here, which is 6, 7, 8, 9 is 9. Okay, so my x is equals to 9, because here is our x, right? Is our x, so this is 9. So there it is, my answer, x equals to 9. That's all. Even shorter than the example 2 when you're working, right? Use your graph is easier basically. Okay, so that's all for example 3. So it's now your turn. Question 3. Okay, this is a question. You can screenshot and print it out and stick into your notebook, or you choose to copy also can. Right? So first step, you don't construct a table because you are not given any big Y and big X. So you're gonna reduce this first according to example 3. If you follow my example 3, I believe your question 3 you can do it, huh? So remember this one also. Use your graph, use your graph. You must use your graph to find the answer. Okay? So before build the table or construct the table, you have to reduce first. Okay. Now I'm gonna give you a hint on your x-axis and y-axis. Huh? So what I want for your x-axis is, I'm gonna write here. So for x-axis, your 2 cm 2 units. So y-axis 2 cm 1 unit. Okay, you can follow this. Right, that's all for lesson 21, which include your example 3 and question number 3. Okay, that's all from me today. Bye guys.